Have you ever been using an app and just stopped to wonder, how does this thing actually work? How could it handle millions of people all at once without just falling over? Well, in this brand new series, we're going to pull back the curtain on the art and science of system design. We're going to show you exactly how it's done.
Okay, so let's just dive right in. We're not going to start with a boring definition. We're starting with a problem. It's a high-stakes problem that, honestly, every tech company dreams of and also secretly fears. You've built something incredible, people love it, and suddenly, boom, you've gone viral. The traffic is off the charts. What happens next? Well, usually the dreaded crash. But why? What's the first thing to actually break? Well, the villain of our story is right here. It's called the single point of failure. Think of it like a domino. It's the one piece that, if it falls, brings the whole system down with it. In a really simple setup, your app server, your database, heck, even your router could be that one single point. One component gets overloaded and goes down, and just like that, your viral app is offline for everyone. Not good.
So, how do we fix this? How do we build a system that can actually handle millions of users without even breaking a sweat? This, right here, is the core challenge of system design. It's all about getting rid of those single points of failure and building for massive scale. So let's start that journey.
Okay, step one is to bring in a load balancer. The best way to think about this is like a really smart traffic cop for the internet. Instead of all the traffic piling up on one server, the load balancer directs requests across a whole fleet of them. It can do this in a few ways. Maybe it sends requests to each server one by one. That's called round robin. Or maybe it sends it to the server that's least busy. But the goal is always the same. Make sure no single server gets overwhelmed. All right, so now our web servers are sharing the load and they're happy. But guess what? We've just created a new bottleneck, the database. Now all those servers are trying to read and write to the same single database. The solution here is something called replication. We set up one primary database that handles all the writes, the new data coming in, and then we create multiple replica copies that just handle the reads. This not only makes things way faster, but it also gives us backups, which is awesome for reliability.
But we can go even faster. Let's introduce caching. Think about it. Why should we bother the database for data that everyone is asking for, like, say, the top 10 trending videos? A cache keeps that super popular data in incredibly fast memory. And trust me, getting data from memory is ridiculously faster than pulling it from a disk. This one change can make a massive difference in how fast the app feels to the user.
So what about those tasks that take a long time, like processing a huge video upload? You don't want the user to just sit there watching a spinning wheel. That's where message queues come in. It's a really clever idea. The web server just drops a little note, a message, into a queue that says, hey, process this new video. Then, a totally separate group of worker computers, the consumers, picks up that message and does all the heavy lifting in the background. This decouples our system, which is just a fancy way of saying each part can work and scale totally on its own. It's a game changer.
And here it is. This is the goal. You take all these pieces, the load balancers, the replicated databases, the caches, and you duplicate the entire setup in different data centers all over the world. Now, a user in Europe gets served from a data center in Europe, and a user in Asia is served from one in Asia. This is what a real global-scale architecture looks like. It's fast, it's reliable, and it works for everyone, no matter where they are.
So now that we've got the basic building blocks down, what kind of cool stuff can we actually build? This is where things get really, really interesting. You see, this explainer, it's just a beginning. It's the official launch of our brand new playlist on system design architecture, and I want to give you a sneak peek of the deep dives that are coming your way.
Think about the last notification you got on your phone, right? Maybe it was a text message, maybe a news alert. How in the world did it get to you instantly at the same time as millions of other notifications were being sent out? Well, in our first deep dive, we're going to explore the incredibly complex systems that make that little ping possible.
And just take a look at this. It's not just some simple box sending a message, right? You can see all these different components for things like authentication, rate limiting, which is crucial to prevent spam, and even analytics. We're going to break down what every single one of these pieces does and why they're all absolutely vital for making sure your notification shows up instantly and correctly.
Next up, we're going to tackle one of the biggest challenges on the entire internet. How do services like YouTube or Netflix stream mind-boggling amounts of video data? We're talking petabytes. Thousands of hours of video are being uploaded every single minute. Seriously, how on earth do they manage that?
We're going to get into concepts like this. Now, I know it looks complicated, but it's a really cool idea called a directed acyclic graph, or a DAG for short. Just think of it like a recipe for processing a video. Each step in the recipe, like creating thumbnails or making different quality versions, can happen at the same time as other steps. It's an incredibly powerful way to make a very, very complex job run much, much faster.
We'll also dive into the super high-stakes world of payment systems. This is a domain where there is absolutely zero room for error. When you're dealing with people's money, correctness, security, and rock-solid reliability are everything. So, the most crucial thing here is understanding how these systems make sure every single penny is accounted for. This diagram shows a process called reconciliation. You can think of it like balancing your own checkbook, but for millions of transactions a second. The system is constantly checking its own records against the bank's records and the payment provider's records to make sure everything adds up perfectly. It's the financial safety net of the entire digital economy.
All right, so you can see how this all builds. But system design isn't just about knowing what a load balancer is or how a message queue works. It's about developing a certain mindset. It's a way of thinking about problems, about trade-offs, and about solutions, just like a real architect.
This quote right here, it really gets to the heart of it all. You know, a great architect knows that the goal isn't to find the one single perfect answer, because honestly, it probably doesn't exist. The real skill is in the process itself, asking the right questions, weighing all the pros and cons, and being able to clearly explain and defend your choices. And this table is a perfect example of what we mean by trade-offs. Look, you can see that while this erasure coding thing is amazing for durability and saving storage space, good old replication is the clear winner when it comes to raw performance. So which one is better? Well, there's no single best answer. The right choice depends completely on what you're building. Are you optimizing for cost, for speed, or for making sure the data is super, super safe?
The source material even gives us this fantastic checklist. And if you look closely, none of this is about specific technology. It's all about communication and critical thinking. Ask questions, understand the real problem before you start solving it. Brainstorm different options. This is exactly how great systems are designed in the real world. It's a thoughtful, collaborative process.
So, we've built the foundation. We've toured some of the incredible possibilities. We've seen how you can get from one little server to a massive global service. And we've peeked behind the curtain of the apps we all use every single day. So, what's next for you on this journey?
Well, this was just the kickoff. We are so excited to be officially launching our full System Design Architecture playlist. We're going to guide you through every one of these topics and so much more. We'll break down each system, piece by piece, giving you the mental tools to really understand and maybe even design your own large-scale systems one day.
What we're doing here is giving you the blueprint, a blueprint to understand the digital world that we all live in now, from social media to video streaming to how you buy things online. So we're going to end this introduction with a question for you to take with you. You have the blueprint. What will you build?